Here we describe each of our analyses and the visualizations we used to understand them. We produced this visualization to highlight how a given URL request would produce NER results. As there were an exceptionally high number of requests, and often 10 to 100 NER results per request, we designed this visualization to be collapsible. That way, we don't obfuscate the results among thousands of other requests, and we can see exactly which NER entities were extracted for each individual domain. Here we show the frequency of extracted entities from the Common Crawl dataset. In comparing the crawler's request manually with a sample of HTML metadata files within the resulting entities, we found that 31 out of 50 were effectively targeted, but the remaining were either a poor choice, ambiguous, or unclear whether the page was a good match. To get a feel for how much data we can get out of any given document, we compare the file size to the metadata size. This visualization shows 4 of those MIME types and where the ratios lie. For text files, a lot of our files got around an 18%, whereas for XHTML, it was a highly left-shifted distribution. We want to understand how much text and metadata was actually obtained by using the parser call chain. We use Tika's metadata extraction and text extraction capability with a random sample of the Common Crawl datasets. In our case, average extracted metadata size is 11.48% of the file size, and the average extracted text size is 84% of the file size. Here we show a demonstration of the parser call chain with an interactive graph that shows the text data size, the metadata size, and the file size for sample XHTML files for each type of parser that is used. This interactive graph shows sample XML files. We also want to know what is the distribution of different languages within different MIME types. On the top right corner, we have HTML files, which are predominantly in English, but there's also some Spanish, French, and German. It's the same story for PDF files, text files, and XHTML files. But you'll notice that within text files, we have a little more French, a little more German, and a little more Spanish. Out of the many languages, most of them are too minuscule within the dataset to show up on the D3 plot. This is the distribution of different languages across the Common Crawl dataset. We find that things like Polish and English, French, and German show up a lot, and the other ones don't show up so much. We had to use a log filter so that we could actually see the smaller ones, because there's such a big difference between the things that are the highest and the lowest frequency. This is a word cloud that shows us the distribution of different terms within the metadata. This one shows us the distribution of different words across only the extracted text. We went an extra step and incorporated suite co-occurrence distributions to show which suite concepts showed up together across most documents. We did multiple extra credit programs, including implementing this in Spark, launching instances on Amazon EC2, writing our own Solar Docker files, and designing our own Grobit service. This is our interactive visualization of the different NER extraction algorithms. We found that NLTK found 66 instances across our sample, while NLP and Core NLP only found it 26 times. But interestingly, different countries have different distributions across different groups. At a certain point, when there isn't much congruence between the models, we throw them out. We did this for as many entities as we could find where there was a significant union. For the Grobit quantities section of this report, we decided to combine all 4 figures into one dynamic figure so that you could actually compare different results from different sections. For instance, we can look at what the percentages were across all of the dataset. But we can also do it for just one element, for one domain. We've done this for across the entire dataset to view the descriptive statistics across each individual variable, and we've done it for one type. We found that this was very interesting, that Fahrenheit and centigrade were two different distributions. So as extra credit, we combine both of them into Celsius. And finally, we did analysis of just PDF files to see what months, percentages, days, and minutes are represented within only those particular files of that MIME type. We look forward to hearing your comments about our analysis.